So for my next review, I wanted to talk about the nitrogen cycle. And something that's important to know about nitrogen is that most of our nitrogen does exist as nitrogen gas in our atmosphere. But that nitrogen gas, N2, has a very strong triple bond that makes it hard to involve in reactions because it's very stable as is. And one of the reasons why the atmospheric nitrogen is not considered like a really useful part of the nitrogen cycle is because that nitrogen is very stable and not involved in reactions. However, that nitrogen can be converted to a usable form through fixation. And so fixation helps to take that atmospheric nitrogen and turn it into a form of nitrogen that we can use, like nitrates and nitrites. The way that the atmospheric nitrogen becomes nitrates and nitrates, which I'm going to put here, is mostly due to bacteria in the soil. So bacteria in the soil are a very important part of the nitrogen cycle, but a small amount of the nitrogen that's fixed is also fixed through lightning strikes. So you'll see lightning strikes usually in diagrams of the nitrogen cycle. The bacteria in the soil are going to be like a bigger component there in terms of transforming nitrogen in the atmosphere to nitrates and nitrites, which are important because those can be used for plant growth, and plants need nitrogen to grow. So those are some plant roots, and here we have some plants above the soil using the nitrogen to grow. Fertilizers also contain nitrates, and so when farmers add fertilizer to the soil, that also adds nitrates to the soil, which can help the plants grow, but can also lead to excess nitrogen in the soil. When you have too much nitrogen in the soil, we know that that can lead to some of that nitrogen running off into nearby bodies of water. And then those bodies of water, we'll add a little river here, can have a problem called eutrophication due to algae that overgrows and then dies. And when the algae overgrows and then dies, that might relate to the carbon cycle because that decomposition requires oxygen, and that leads to oxygen levels going down and carbon dioxide levels going up. So that's where we see the nitrogen cycle and the carbon cycle overlapping. When the excess nitrogen in the soil ends up in the water, that leads to eutrophication. Could even draw some algae in the water to represent the algal bloom. When algae blooms, it also blocks light getting to the plants that are below it, and so that can have another impact on the carbon cycle. So we have nitrogen in the atmosphere that's fixed by bacteria to form a version of nitrogen that can be usable by plants. Those plants are also consumed by living things like animals. Here I'm going to draw a little cow. And that's important because the cow assimilates that nitrogen that it gets when it's eating the plant, but eventually the cow has waste products that go back into the soil. So the cow's waste products are also an important form of nitrogen. It's called ammonia. And when the cow dies and decomposes, the nitrogen from the cow's body also returns to the soil. That ammonia can also be converted by bacteria into nitrates and nitrites. So plants can use ammonia, but then some of the ammonia is also transformed back into nitrates that plants can use more easily. And that process is called nitrification. I think it can be confusing to know the difference between nitrification and nitrogen fixation. So think of fixation as transforming atmospheric nitrogen into ionic or solid nitrogen. And then nitrification is just taking that one form of nitrogen, which is ammonia, and transforming it into nitrates or nitrites. Finally, in addition to these processes, we also have the more anthropogenic process of vehicles, which as vehicles are driving around consuming fossil fuels, this doesn't have to be a vehicle, it could also be a power plant. So we could have a vehicle here with an exhaust pipe. We could also have a power plant that is producing exhaust. When fuel is burned in the presence of nitrogen, which we said that most of our atmosphere is nitrogen, when fuel is burned in the presence of nitrogen, there is enough heat involved with combustion to actually break these bonds in these nitrogen molecules. And in that case, some of the gases that are released are NO or NO2. So we refer to them as NOx because it can be NO or it can be NO2, and those are released by both power plants and vehicles, especially coal. If you remember from the carbon cycle, that coal is one of the less pure fossil fuels, and so it contains nitrogen as a component. So that can also be released when you burn coal because of the nitrogen in coal. So that NOx that's released combines with water in the atmosphere to form acid precipitation. I'm just going to use that to represent the acid precipitation, and that is known as nitric acid, which also has the formula HNO3. And I think knowing the name or the formula would be fine, but nitric acid is one that you should know about. And then that nitric acid can dissolve mostly like stones that are used to build buildings, stones that are found in nature. When acids dissolve the stones that are found in nature, they release heavy metals and other metals into the groundwater and the waterways, and that can affect organisms that are impacted by metals that aren't usually present unless they're being dissolved out of stone. And so that's where we see the anthropogenic and the natural sides of the nitrogen cycle coming together, both with the fertilizer, which can lead to eutrophication if there's too much, the same way that fertilizer can help the plants grow, can help algae to overgrow. And then the nitrogen from the air, when it is converted to nitrogen oxides through combustion, that can lead to acidification, and it can also lead to photochemical smog. So remember that NOx is also a compound that can react with oxygen to form ozone and photochemical smog. So you could also link that to photochemical smog. Both acid deposition and photochemical smog are considered secondary pollutants because the primary pollutant is the NOx, but the compounds that react with NOx to form new pollutants like smog and nitric acid, those are considered secondary pollutants, the result of those reactions.